Hi everyone, I am Harish. This video I am posting to explain about one of the application of Pascal's law. That is when a container having the fluid inside is being accelerated horizontally. It is observed that the surface of the fluid becomes inclined to the horizontal. So that is how it happens. We will see by this video and we'll do a small derivation to arrive at the angle of inclination made by that surface of the fluid when the container is being accelerated horizontally. Hope you will enjoy and you will learn by this video. Please keep watching this video. Thank you. Let us begin with a container which is kept on the ground like this, and it is filled with a liquid up to a certain height like this. In this case, since it is kept horizontally with respect to the ground, the level of the surface of the liquid, this one, is also horizontal, that is parallel to the ground, the reason being acceleration due to gravity acting vertically downward. Even if we tilt the container, the tilting of the container will not affect the surface of the liquid. For example, if I draw the situation like tilting of the container in this way, such tilting of the container will not affect the surface of the liquid. Rather, the surface of the liquid will remain still horizontal, that is parallel with respect to the ground. The tilting of the container does not affect the surface of the liquid. That is, there is no tilting observed of the surface of the liquid because the acceleration due to gravity is still acting vertically downward. But let us take another case in which the container is now being accelerated towards right direction with a certain force. Like this. An external force is applied such that the container starts accelerating with, let us say, an acceleration of A in the forward direction. As a result, now the surface of the liquid will become tilted. I will show that situation now by drawing it once again. So the same container now being accelerated horizontally, and if we draw it, the surface of the liquid now will be tilted in this way. That is, the surface becomes inclined with respect to horizontal. If we draw the horizontal level, it is making, let us say, an angle theta. The surface of the liquid is now maintaining an angle theta with respect to the ground when it is being accelerated horizontally by a certain acceleration length, let us say A. We will mark here a level rise on the left side as h with respect to horizontal direction, and let us say length L is the base length of the container. We will mark here some of the points based on which we are trying to find the angle theta, that is inclination of the surface. Let us mark those points first. We mark point 1, here point 2, and point 3. First of all, let us try to understand that why this inclination has happened. The inclination has happened as a consequence of the fact that the container is being accelerated horizontally. Because of that, the pseudo force being applied on the fluid, on the liquid with respect to container in left direction, like this. As a consequence, there is a pressure difference created, that is, pressure on the left side is more than the pressure on the right side at the same level. Because of the application of the Pascal's law, just like in the vertical direction, we used to say this fact that pressure increases with the depth because of acceleration due to gravity. Same way here also we can represent this fact in the horizontal direction because of the pseudo force being applied on the fluid with respect to the container. There is a pressure drop, or you can say pressure difference created, that is pressure at 3 is expected to be more than the pressure at 2 by the same application of the Pascal's law. Let us write that in the form of expression. So immediately can we say that location 1 and location 2 are exposed to the outer atmosphere. So they are expected to be at the same pressure. We can write immediately pressure at 1 should be equal to pressure at 2. Now apply Pascal's law both in vertical direction, that is comparison of point 1 and point 3. Also we will write Pascal's law for horizontal direction, that is point 2 and point 3. Begin with point 1 and point 3. Can we write from the Pascal's law statement that pressure at 3 should be equal to pressure at 1 plus rho gh. Rho is the density of the fluid. G is acceleration due to gravity. That is how P3 is equal to P1 plus rho gh. Further, along horizontal direction, applying the same Pascal's law as a consequence of this pseudo force, we can write now P3 is equal to P2 plus rho Al. We have three equations. By comparison of these three equations, we can immediately write rho gh is equal to rho Al. From this, I can also write, or we can simplify it in the way h by L is equal to A by G. Referring to the right angle triangle marked by 1, 2, 3, h by L can be written as tan theta. Therefore, I get the angle tan theta is equal to A by G. This is the derivation we wanted to find out. That is the inclination angle theta of the surface of the liquid in the case when the container is being accelerated horizontally. The acceleration is affecting the value of theta, and the entire phenomena is now clear to us, which is entire thing is based on Pascal's law that we have derived here. Hopefully it is clear to everybody, and I will bring more such videos to explain some of the important concepts of physics. Thank you for watching.